Hello everybody. This is the recorded part of lecture 7 regarding automatic stacking. In the lecture we studied how to prepare the program for the automatic stacking. Here we have two belt conveyors that one of them transfer the plates and then they stack on the other one. So during the time that the plates are, let's say, transferring by motor 1, conveyor 1, the conveyor 2 stops, and when there are sufficient number, 5, 7, any number that we set, then motor 1 stops and motor 2 starts to move them and clear the space for the next stack. To detect that there's a plate dropped or transferred from M1 to M2, we have a photosensor that when one plate dropped from M1 to the M2, then this being disconnected and the light sensor, the photosensor detects it. The program is this one. We prepared this during the lecture, and this session we are going to build that in PLC. Also regarding we use on timer for the motor M2, also a counter that counts the number of the plates in each stack. Then this is the HMI. In this HMI, they have two conveyors, conveyor number 1 and conveyor number 2. The photosensor that detects there's a beam, that when the beam cuts is cut, then it means that there was one plate transfer from M1 to M2, and when the number of them reach to that one, 5 in this example, then M1 stops and M2 starts. And in this HMI we want to also have the animation of moving these slowly to right, compared to the automatic feeling that it was just disappeared, visible and invisible, with the beam was just disappeared. But this time we're going to gradually move that to right and then clear the space for the next. And there's also a counter that the number of the plates are counted here. Okay, so let's prepare the program. Okay, again the PLC file is ready, and then we're going to build the program over there. So let's again look at the program. Let me again a little bit enlarge the size. Okay, that's the size. Okay, we need normally open here and then on timer and also this structure. So let's first build this part and then the structure of that, and then go through this. Let me just mention something. In this example, just as a practice, instead of having the start-stop from the HMI, we again use the start-stop from switches. But these start-stop can be moved to the HMI, and let's say remove these physical one. But the photosensor should be still physically, and we need an input for the photocell and the sensor. So we cannot replace this by HMI. We can indicate that, the state of that, but not replace. But for the stop and start, we can just use the HMI. But in this example, just as a practice, we use switches. Okay. So let me start. We need a normally open and also a timer, an on delay timer. Okay. This was for the motor 2 running. I think that was the title. What was the title? Motor 2 runtime or running. And then we need this structure. So let me build this one in the same network, or maybe the other network, just simply this one, this, and then here we need a branch here with a normally open, normally close, back, and another one again here with another branch. This just I think it normally open, and then just simply connect it to here. Okay, so this is this structure. Okay, and then this should be a stop, Q07 for the motor 2, this I01 for stop, and this I00 for start. So let's build them. So I01 just for stop, and this I00 for start, Q07 for the motor. Motor 2, 10 seconds, 10 T, let me remind, T sharp 10 seconds, and then I don't think that we need the, oh okay, maybe we need that, let's see, yeah, MD, motor 2 running time, MDB 20, motor 2 running time. Okay, and then here this Q0.6 for motor 1. Okay, and then okay, here motor 1, here motor 2. This is the, okay, another timer that we will reach to that, but this is also motor 2, the Q of this motor 2. Okay, motor 2, the Q of this, and here we need motor 1, and here motor 2. Okay, so motor 2. Motor 1, okay, and here motor 2 running, runtime Q. Okay. Oh, okay. Here in the figure it is motor 2 runtime, but in the program I made it motor 2 running. If you want to make it the same, it's not difficult. Just open this, okay, just directly from here, let me do that from here. If you change this, the tag of this, rename the data block, run, okay, and you see that automatically this also changes. An alternative method is to look at these PLC tags, okay, and then show all tags, and then here you can change the name, the tag, the tag of them, or even the address of them. Okay, but in our program, okay, let's later we will add this one. We have not yet built that part. We will reach this point later. Then the rest is this. We need a normally close for the photosensor, and then a count up counter. A count up counter with 5 number preset value equal to 5. And this structure, this just assigning, and this as a pulse. Okay, let's build this part and then the rest. So here I normally close, followed by a counter. Counter can be found here, counter operations. Okay, count up. This is the one that we need. So double click on that, and then okay. What was the title of that? Number of plates. So this is the number of plates, the title or the name of that. Number of plates. Okay. And this is the photocell. Input 0.2. And the title is, I think, photosensor. Photosensor, yes. Photosensor. 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 Good. And the preset value of that is just 5. Yes. Okay. Then, of course, we need a resetting, but we will reach to that later. Yeah, we can of course add it here, M0.0 and MW11 for the output number, MW11. So MW11, this is the number that we later using our HMI. It's called stacked plates. So let's change that to stacked plates. Stacked plates. Okay, and here M00. It was M00, yes. Yeah, M00. And also we need this structure. So M0.0. And the tag of this is resetting. Okay. Also we need this branch we normally open, and this one. Okay, we have motor 2 here and number of plates, the Q up of this one. Okay, so here number of plates, and you see, oh, sorry, once more, number of plates. Okay, when you click on that just once, a few seconds ago the error was because I double click on that, just one click, then we need QU. Okay, for the up, and this should be Q0.7 for motor 2. Yeah, the command to motor 2. Okay. Also we need this timer, just a 1 second timer to trigger a short pulse to stop the motor when the motor 1 when the motor 2 starts. So let's build this one, stopping motor and motor 2. So here also let me when the motor 2, then stop pulse timer. Okay, stopping motor 1, and this is motor 2. When you have the command to turn on the motor 2, just for a short second, short pulse, just 1 second is sufficient. And we don't need the output of stopping motor 1. Okay, this is the one that will be used. Okay, this is the one that needed to be used at this point. Okay, to turn off the motor 1, which was continued to be on by the self-holding. To reset the self-holding by motor 2, so it is motor stopping motor 1, the queue of that. Good. And finally, the last part of the program is this part. Motor 2 runtime. Okay, if this becomes queue or the stop command comes, then we should reset the counter. If the stop commands come, we reset the counter. So either this one or we have the this should be normally close. Okay, and then normally close of this and then go back. So either motor 2 runtime queue or stop, then resetting. This is the resetting. The counter resets. Okay, perfect. So now we have all the program. Let's just check that. Motor 2 runtime. Queue, the stop it normally close, this one, and here we have motor 2 and the stopping motor 1 with 1 second. Motor 2, and this is number of plates. Yes, and motor 2. For the counter, photo sensor, and count up. Photo sensor normally close, count up with number 5. This is resetting, and then W11. Okay, yeah. And if you go up to check to be sure that input 0, 1, input 0, 0, Q07. On Q07 and the motor. That's good. And here motor and stopping motor. Motor and stopping motor. And this is motor 2 run Q. Motor 2 run time Q. Okay, perfect. And here just simply motor 2 and an on delay with 10 seconds. Motor 2 with on here 10 seconds, and okay, that's good, perfect. So the program is similar to the program that we had in the lecture. So let's compile that again. Okay. At the end of the compilation, there's not any error. Here you can see, and also if you go down at the end, you see no error. That's good. And so let's download that. Okay, connect, start. Okay, I forgot to change the address. Let me also change the address to 207. Okay, let me show you something here. Here is the compatible device. We generally use this, and since this device, the 207 that we have in our desk trainer is compatible. The type of that is compatible to the selected PLC in the software, in the program. It showed us this to us. But let's this time use the same address. It search for this address. Let's see what happened. Okay. Wait until this enables. That shows that the searching finishes. Okay, you see, nothing, no, there's no PLC with the same address. It could not find any PLC with the same address. This address is not correct. So see that there's different options, the same address, the same compatible device, or any accessible device. So let me just cancel this for a while, and then in the PLC change the IP address of this, double click on this one, and then here you can see, okay, 207. And then again, download. And this time, again, let's search for the same address. Okay, you see, this time it could find that. And then load on that. Let's load. Now it asks, continue without synchronization, yes, no action because it is not in the stop mode, stop that. And start. Okay, so the PLC program has already been downloaded and the PLC is in the download. Let's work on the HMI part. We'll see the result for the PLC later. Okay, for the HMI, going to the root screen. Okay, let me increase the size. Okay, this is the HMI screen, the root screen. Let me remove this message, we don't need that. Then we are going to build this HMI screen. This is screen, okay. Here by a rectangle, these are rectangle, this is also rectangle, but we just round them to indicate that they are conveyor, and we need some rectangle also here. So let's first build this part, and then one by one the other parts. So just a simple rectangle here. Okay, this is our conveyor number 1, and we need also another conveyor. You see, we need lots of space, so don't make it too large. Another conveyor here. Okay, conveyor number 2, and then also one rectangle here for the plate, and another one here for the other plate. Okay, that's good. Okay, to make these round to looks like as a conveyor, you remember that we use okay, double click on them for the appearance. For the color, a little bit more darker gray would be very good. Layout, of course, it's just you may keep the same, but here you see that this is how to round that. We want to round that in this direction, so let's change that to 100, but you see, okay, you can see here, let me increase the size again. Okay, make it 0. Okay, so from the Y direction it's going to be round, but since the X direction is 0, you cannot see anything. But when I increase this, the corner radius from the X direction, you see that it round. Oh, that's sufficiently good. Okay, this is. And you're not going to add the shape of a motor. Instead of that, just simply change the color of this when the motor 2 is on. So let me add an animation here. Appearance. And then connect this to the command for motor number 2. So every time that motor number 2 is on, it's okay. Then if it is 0, nothing. If it is 1, then change the background color to green. So this conveyor turns green when motor 2 is on. That's sufficient. We don't need anything more. Okay. Similarly for motor 1. Okay. Similarly for motor 1. Let me bring it a little bit low. Similarly for motor 1. You can add a little bit around that. Not that much, but a little bit maybe would be good. Okay, this you can change that a little bit more if you like, but that might be sufficiently good. The one that we have in the okay, this is how it appears in the lecture slides. Okay, this also for the animation. Let's add an animation regarding the color change when motor 1 is on. So let me, okay, here the tag motor 1, and then motor 1 is on, just this. Okay, good, perfect. So we will work on these plates later, but let's add another part to that. Okay, and that is this part, photosensor, a beam, and okay, here something that just as animation. If there's not any plate here, we expect that the beam reach to this point. But when there's a plate transfer from M1 to conveyor 1 to conveyor 2, during the time that it is moving, so the photocell beam cuts. And so in that case, we expect that here we have the beam, but the beam cannot reach to this point. That's good to have animation to indicate that. So, okay, so let me add some rectangle lines and then work with that. Let's add one simple rectangle here for the transmitter of the photocell, with a line at this point and another line at this point to as if it is the wire. They are wires. Okay, so this is the transmitter and another one for receiver part of the beam. I want them to be in the same, so select this, push the shift key and select the other one, okay, or use these to, okay, select both of them and then let's align them to the center. Okay, they are aligned. Good. And then one beam from here, but I'm not going to add the beam, this beam to this point, because this part remain on. The color is this part of the beam is, let's say, it is visible all the times, but this part of the beam must be invisible when there's a plate in front of that. So I separate these two parts, this part of the line and another line from here to the beam. Okay, good. So it looks like this is just one line, but in fact it is two lines. The first line let me change the color of that. The color, yeah, for the beam, a good color could be yellow, so change the yellow. Yeah, that's good. And this one also, change the color to yellow. Okay, so this is the beam. The color for this one, okay, let me also add one more line here and another line here, just as if they are, okay, and another line, oops, from here to here. Okay, it just try to mimic that it is a kind of wire. They are wire. Okay, just simple. Okay, good. Okay, the color of this beam is going to be changed if there's a plate in front of that, to indicate that okay, there's a the beam is not reached to this point, or let's say there's a command, there's a input to the PLC. So I change the color of that again. Okay, according to the photosensor. If the photosensor is 0, if the photosensor is 0, photosensor 0 is, let's have a look to this diagram. Okay, photosensor 0, it means that there's not any plate. Okay, when there's a plate, okay, when there's a plate, it closes. It closes. So there's not any plate. So when we have, in that case, it is 0. So in that case, let's assume that the color is this, nothing changed on the color, but when there's a plate here, so when the photosensor is 1, then let's this to change to, I don't know, for example, orange, to mention that okay, there's a plate passing. And this also should be invisible, visibility of that. It should be invisible when the photosensor sends something. So when the photosensor sends something, since that there's a plate there, this becomes invisible. It is invisible because the beam cannot reach to this point. If there's not any plate, it is visible. Okay, good. Then this is this part, and then the next part is this. In fact, here we need some rectangle with the same lanes as these, but of course the direction is different. The direction, this is from the top view, but this is from in the side view. So we need 5 plates that in fact indicates that the plates, every time that the plate transfer from conveyor 1 to conveyor 2, 1 plate appears here. So I need 5 plates here, and also 1 plate just to as an indicator that there might be a plate in the way of transferring from conveyor 1 to conveyor 2. Okay. So to be sure that we have the same size, okay, I do this. I copy this, and so I copy this one and paste. Okay, so I know it is the same size, but I reduce the vertical. So it shows that, okay, from the horizontal point, they are the same. I need 5 of them at least. We'll see that we need even more. All of them, okay, so one by one, put them in the top. An alternative is that you select all of them and then use this to, Okay, adjust them all to the left. Okay, so they are adjusted all to the left, and then one by one move them up. So this one here, the next one here, the next one here, and the next one here. Okay. So I have 5 plates, and one more plate to be here. Yeah, this plate should be visible only when the photocell sends that. So let me add an animation to that, a visibility animation, and make it visible when the photocell sends that. Otherwise, it is invisible. There's not anything here. So when the photocell sends this, okay, it is visible. So 1 to 1. So when photocell sends a plate is transferring, it is visible. Otherwise, it is invisible. And then, since this is invisible, the beam reaches to this point. Okay. But regarding these, okay. Okay. I need a counter here. Let me add the counter also. The number here. Double click this point. Okay, and then the properties of that. Okay, general. The value of that, it is connected to the counter output. Where was that? Stacked plates. It was a stacked plates. M11, MW11. Yeah, MW11. You remember? Let me show again here. Yeah, this MW11 stacked plates. So let me use this tag, stacked plates. Okay, so the value of that changes by stacked plates. On the other hand, it is a positive value, so we don't need, and since you have just 5 plates stacked, so we don't need more digit, just one digit is sufficient for that. 0, 1, 2, 3, finally 4, and finally 5. Okay. And then one by one, these are going to be appear if, for example, this one should be visible if there's at least one plate here. The second one should be appear, must be visible only if there are at least 2 plates. So I add another visibility to them here. Okay, I add a visibility to them and says that okay, this must be visible according to the stacked plates if the stacked plates are from 1 to the maximum possible value 5. Okay, in this case it is visible. So if the number of the plates here is 0, it is invisible. If it is 1 to 5, it is visible. Okay. The second one, this one, is going to be visible similarly. Its visibility changed by the stacked plates, but this time it is going to be visible if there's at least 2 plates, 2 to 5. The maximum number is 5, so 2 to 5. This one, visibility, from 3 to 5, and then this one, visibility 5, and finally this one if there are at least 5 plates. So it should be visible if there are at least 5. Okay, that's good. So this is regarding the visibility. The other thing is that we want to have it moving, to show that they are moving. So to build that, we can do something like this. Okay, yeah. Moving from here to here. Okay, so they are moving from this point to this point. Let me a little bit move this to right. So okay, they are started from here and then goes to somewhere here. So for moving, okay, let's add the two-way. Let me just work on. There's a movement option here, so you can move that, add, move them, and horizontally we want to horizontally moving them, and connect that. Okay, to connect it to what? Okay, they are moving when the motor 2 runs, and according to the program, motor 2 runs during the time the timer is running. Okay, this timer during the time during the time in the period that this timer is counting the time, and the time is indicated by this MD20. So we can tag this MD20 to this plate and use that to move that to right. Let's do that. So let me tag this motor to running. Okay, and their range is from 0 to 10 seconds, but please notice that the time is based on milliseconds, so from 0 to 10 thousandths. Okay, this is 100,000, 10 thousandths. Okay, from where to where? Initially it is at this point, and not because we want to move that horizontally, so the y dimension is the same, the y coordinate is the same, but for the x it moves from here to here. If it is 459, maybe a little, that's good, maybe a little bit more. Let's change this to, so you can, start position is here, the target position, it by default give you some value. As a value you can change that. For example, let me change that to 500. Okay, move that a little bit more. So during the time that this value, this motor 2 running time changes from 0 to 10 thousandths, during that 10 seconds, this plate moves gradually to right and moves from here to here. Similarly for this one. So for this one also, let's add a movement horizontally. Similarly connect that to motor 2 running time from 0 to 10 thousandths, and this also to be 500. Okay, this also. Horizontally. Okay, let's see. And then from 0 to 10 thousandths, and this one also to 500. This. Good. And finally this one. Motor 2 running time from 0 to 10,000 and from here to 5. Okay. Okay, it seems that everything is ready. Only thing that remains, I just want to change the color of this one also. The appearance, it is 0, a little bit darker. Conveyor, this to be the conveyor, to change the color, and also in the appearance also for this one. In the appearance also, let me change the color of this one to this. Okay, that's better. Okay. So yeah, I think that everything is ready, and we don't have any start and stop in the HMI. The start and stop is by the switch. There's one reason that might be better to have that in the local start and stop instead of having that in the HMI in the central control room, because these are some moving elements, particles, and maybe it's better that there's every time there should be a operator close to that and decide whether to start or to stop. It's up to the design. I don't want to say this is something that should happen every time, but there are some justification for having start-stop, local start-stop for this type of process. But this is just a matter of a reason. But I don't want to say that this should be the same all the times. It depends on the process. Sometimes they assume that okay, everything should be happen all through from the central room or anything to be controlled by the central room. Sometimes we prefer that this type of process to be controlled locally by the operator. Okay, this case I assume that it's going to be controlled locally by the operator. Okay, so let's check if there's not any error on that. I think everything is ready. Of course, we can download, check whether it works as we expect or not, and then if it is necessary, do some modification. Okay, there's not any error, so let me download. Yes, overwrite that. Okay, so let's see. Okay, this is the process. Okay, here we have the HMI. We'll work on the detail on that, but here the process. In this process, you see we have two motors, motor number 1 and motor number 2, conveyor number 1, conveyor number 2, and we have a photocell. For our photocell, if I put my hand in front of that, you see that there's something changed. Okay, so every time that there's my hand is in front of that, it senses. It doesn't have the second receiver. The root transmitter and receiver are in this device. Both of them are here. So it is different from this shape that there is transmitter and receiver. But just let's look at that. Okay. So it's working. Okay. Start and stop are here. So let me first stop that. Okay, there's something wrong here. When you stop that, also where's the reset button? I think there should be a reset button also. Maybe I forget to add the reset button. Resetting. Okay, where's the reset? Okay, stop, reset. Okay, but reset. So the counter is 0, but these are visible. So it seems that there's something wrong in the visibility of them. Let's look at these. These are these two. Okay. Regarding the visibility of them, visible when it is between 4 and, oh okay, the tag, I forget to give the tag number of that. The tag is this stacked plates, and this one also, yeah, I forgot to give this stacked plates. Okay, and download. Okay. So let's start the process. Okay. See, the conveyor number 1 starts. This is running. This is running. And so it means that the plates are transferred. Then every time that the plate transfers from here to here, the photocell sends them. So when I see, 1 plates appear, I don't know, oh sorry. Okay, let me reset that again and then start from it again. I forgot to, okay. So, let's start. Yeah, here you see, let's change the color, change to green, so it means that it is running. And here you see also that this motor is running. Okay, then every time that the plate transfer from this conveyor to this conveyor, the beam goes, and so it means that there's a 1 plate transfer. Let's do that. Okay, 1 plate. You see, it is 1 plate appears. Again, 1 more. 1 more. Okay, and let me just show you something. This is the 4th one, and here you see that when this appears, there's not any beam. Of course, it's not that clear. There's not any beam. This part of beam is not visible, and the color of this sensor also changes, which is an indicator that okay, a plate is transferred. And then, okay, reach to number 4, and let's see what will happen when it is number 5. Okay, number 5. Okay, and here you see the plates are moving to right, and when they reach to the final destination, the motor stops, and we assume that there's, okay, they have already transferred to another conveyor that is not shown, so they are transferred all of them here, and then it's ready for new plates. Okay. Oh, okay. It's because 1 more plate. It shouldn't, I made a mistake. It shouldn't be 1 more plate. Okay. Just to let you know more detail. I wanted to show you closer position. It's a bit difficult. Okay. Okay, just to show you better. It's good. And then you see 1 plate up here. this number 3. And then it moves. Perfect. Okay, that's all. Then it stops. Okay, that's all for this session. We built the program and the HMI. Of course, I'm sure that you can make even more beautiful HMI by using the parameters and properties that are given by the TIA. Okay, that's all. Until the next session. Goodbye.